Okay, good afternoon, everyone, and welcome to this online lectures that will discuss about landslides in highway construction. Uh, I started the recording of this meeting. If some of you are not able to be online during these working hours, so you can use the video link later. I'll send the video files so you can follow the lectures if you're interested in to see what was what were we discussing about. Today uh, we won't go very much into details regarding the outline of this course, but we will discuss about some details. What are we planning to do in those 10 hours lecture? We'll define the outline of the course and show you what we'll work on and discuss on. So the title of this course is, as you know, landslides in the highway construction. My name is Adis Keic. I work at the Faculty of Civil Engineering in Sarajevo as an assistant professor at the Institute for Geotechnical Engineering and Geology. At the beginning, when I'm discussing about the outline of these lectures, maybe some of you will be disappointed not to see so many details regarding this subject, but I believe that some useful information will be available and useful for you, for the one of you who decide to follow the course. Of course, the lectures are totally and should be totally interactive. I would like to see some feedback from you involved in this lecture. So I would be very happy if I get some feedback from you, like some questions, like some ask for additional explanation or similar. So I can see in detail who am I talking to, and if any details you're interested in and I didn't mention it, you can always take your time, ask a question, and I'll try to answer it and make it clear if I'm able to. Of course, if you have any questions after the lectures, you can always use an email address I listed here, and you can send an email or ask some question and some that needs to be clear or something. The schedule of these lectures, it's that we plan to do 2 hours per week. We'll have lectures every Tuesday during the month of March. So it's 5 weeks, 5 Tuesdays at 2 o'clock, some 2 hours of online lectures. As I said earlier, we'll have interactive lectures. That means you can stop me anytime you want, asks for some clarification, asks for some additional question, and I'll be happy to make it clear and to discuss about it. Regarding the exam, we won't have a typical exam that we ask you for something and you're giving answers. It will be some kind of interesting content where I will give you one practical example. So it will be we'll prepare this exam question at the end of this course, and I'll prepare one practical examples with soil data input. So you'll all have some slope. There is surcharge by some additional load as some foundation of the structure that is built near the slope area. And then I'll ask you for some input parameters of this material to try to predict the result of this problem. The result can be to predict the bearing capacity of this footing on slope, or just to define the load settlement curve for the problem of this kind. So you will all have some same input data about soil, but you may use some different theories, different empirical approaches, numerical approaches to gain the results, and probably the results will be all kind of different, and we'll then use all of your result to prepare some discussion about it and to try to gain some knowledge regarding this design of some structures or roads on the slope area that is similar to this thematic that we are discussing here. A short description of the curse can be separated in these 5 groups. It's 1, 2, 3, 4, and 5. The first one is the introduction that we'll spend some time today to discuss about this issue, where we will present some basic information about the subject we are discussing. So the name of this subject is landslide in highway construction, but at the beginning we have to separate 2 aspects of this problem. The first one is the building of highway construction in landslide areas. So that's the one possible problem, that we need to pass our highway through some landslide area on some areas prone to sliding or potentially unstable areas. So that's one possible problem. And the other, not very often problem, is that we have landslides activated due to highway construction. So we definitely need to separate these 2 problems. The one is that we have at the beginning, before we are constructing the highway, that is the highway construction in landslide areas. Then we have to be prepared and to construct the highway, to prepare some structure, drainages, and so on, so that the highway construction is functional and stable during the next years of exploitation. But the second problem is that maybe we don't know about the landslide area, or we did know about the landslide area, but we didn't correctly apply the support remediation measure, and we have the problem after the construction. That is also a very often problem, that after the construction, the highway exploitation, we have problems regarding the activation of the landslides in that area. So I'll discuss on some basic information here, and I'll give some local experiences from the highway construction in Bosnia and Herzegovina, with a very some practical examples in both of these cases, A and B. That will also be the first part of this lectures, this so-called introduction, where we'll discuss on some basic mechanisms of sliding, some most often landslide types observed in the local highway construction practice. Second part of the lectures will be the discussion on the investigation works. That means the engineering geological investigation works that are the first part of some route planning before the highway construction, but also later, if some sliding occurs due to highway construction, we can do investigation work just to try to understand the sliding and soil failure mechanism. Additional with the investigation work, we'll discuss about the importance of monitoring in solving landslide related problems. We'll describe different types of monitoring techniques that are used during the remediation of landslides, no matter they are active before the highway construction or after the highway construction. Finally, in this second part, we'll discuss about one very important and very often in practice used design method, that is so-called observational method design. Observational method design will define different approaches of these methods that are really very often used in worldwide and local practice as well. That's not a typical design where you prepare a drawings, you give your drawings to the contractor, and then some supervision follows the contractor to do everything what was designed in some main design prepared by designer. No, the principle is sometimes different. If you want to use observational methods, then you start with the concept of the solution. You start building as the designer for some expected condition, engineering geological conditions, but then you're collecting new information regarding the soil data, monitoring data, observation of displacement, observation of the forces in elements of structures. And when you collect all this data, then you are changing the design solution as the construction works are continued. This kind of observational method, this kind of design can sometimes be very, very, very good regarding the costs of the construction, but also regarding the safety of construction. We will this will discuss in details how what we can construct a safe and economical structure and compare it with some traditional design where the designer prepares the main design and the contractor constructed just the way it was on the drawing. We'll so we'll I'll show you plenty of practical examples where observation methods were used and where observational methods were not used. Comparing the outcomes of these case studies, you'll see that this kind of design can be very, very useful if you want to reduce the costs and if you want to have safe and stable structures, not only temporary during construction, but also in a long-term conditions. Third part, it discuss about some measures, some supporting measures that need to that enables the construction of highway routes in landslide areas, or that enables the remediation of the slopes failure activated after the highway construction. We'll talk about different types of retaining walls, the draining measures used for reduction of pore pressure inside the slope area. We'll discuss about foundations of some viaducts passing landslides. We'll also show plenty of case studies that were used in different phases of highway construction, uh, or the construction type A, where the highway passes the landslide area, or the types B, where we had the slope failure after the highway construction, or actually due to highway construction. Fourth part of this lectures will be to show you some details of computer softwares that are used for identification of failure mechanism at the first phase, and then for the design of remediation measures after we identified and confirmed the failure mechanism that is observed at some particular location. Nowadays, different types of computer softwares are used. Some of them are limit equilibrium based concept, and some of them are stress strain numerical analysis. And there are so many softwares used worldwide. We'll show some details and capabilities of different techniques for solving all kind of problems, like foundation of viaducts in landslide, like remediation of failed slope during construction of the highway, like simulation of some highway route passing landslide that asked for some retaining wall construction or some counterweight design. We'll show different examples and different solutions how it can be combined with computer software programs to predict some safety factor as main aspect, showing the stability of some slope before and after remediation. Part 5 includes case studies and different examples of slope failures during construction of the highway. And all of these case studies are actually a local examples from Bosnia and Herzegovina of some failures and the details of investigation work, monitoring performed, and computer software analysis, and some drawings and details of this remediation measure, and some useful informations, problems and solutions performed during the construction of the highway in these kind of areas. This subject that relates highways and landslides, it can be found in the literature. Well, we are not the only area in the world where this problem is occurring. This problem is really worldwide. You can find plenty of slope failures that use large problems, not only during construction, but even after the construction of highway. Here are some examples from New Zealand. An example for Taiwan, where all the hill practically slide down to this constructed highway. Here is one GIF video showing the failure of the rock slope in California, USA. It's all from the near past to 70, 80, 70. So this is not something new. This is something that is happening very often worldwide, not only a local problem. Why are so many of these failures worldwide? Well, one of the most important problem is actually a route planning. Route planning is really something that a lot of time should be spent when discussing the way some route will be located, will be planned. So it's, people, some expert that is doing the route planning should really have good experience, a lot of experience, and he should be practitioner in not only in one subject, and not only technical engineer, not only a road engineer, not only geological engineer, not only bridge design engineer. It should be a person that knows a lot from all these areas. And it's not easy to find a man with that kind of capabilities. And very often the route passes some areas, and that cause plenty of problems that were not expected during the planning of the road. We'll discuss about this also in some details of these lectures, and I'll try to share some experience and some problems we had locally here in Bosnia and Herzegovina. So maybe that can help in the future to get rid of this problem at the beginning of the route planning, and before it becomes too late and you already have some object structure constructed, and then you start dealing with the landslide prone area, potentially unstable areas, and then you have to spend really a lot of energy, a lot of money to construct a road in such a conditions. And even after that, you're not totally sure that you have a stable, long-term, and safe construction. That's also a part of this last sentence that should be to show you some lessons learned from the failures. Every time we observe some failure, we can try we can easily predict it in the future, and we can escape it in some future work. Some aspects of slope stability we actually want to discuss in this course, and of course, and it's sometimes very it's often a problem during the highway construction. I sorted in two problems. The first one is so-called mud flow, where you have a surface erosion that can influence the functionality, the serviceability of the highway route. And the other problem is rock mass instabilities. Because as it's not that rare that we have some deep excavation, not in soil but in rock mass, and deep excavation in rock mass can be as same as critical as the slopes in the excavations in the soil, especially well, if you have different kind of very weathered, not so firm rocks. But as I said, we won't discuss about that. It may be a part of some other subject, of course, but I found it useful just to say what we will not discuss about. So we will discuss about the landslides in the soils and some stiff clays, soft clays, sandy material, sandy clay material, some typical surface soil, not the surface erosion like we have here, some surface erosion sliding to the highway, or some erosion mud flow that brings this clayly material from the top of the soil and bring it to the to the highway and then influencing the serviceability of the construction. That's one part we won't discuss, and the other part is rock mass instabilities, because every time we have deep excavation, even if it's in rock, it can cause some instability that could bring a lot of problems during and after highway construction. What should be the learning outcomes after all these lessons? Well, first, and that we'll discuss in detail today, it's a typical landslide mechanism. Typical landslide mechanism for the landslides in Bosnia and Herzegovina. Unfortunately, I don't have much experience of landslides worldwide or locally in other countries, but what I can discuss about is the sliding mechanism observed in most of the landslides activated during the construction of highway in Bosnia and Herzegovina. I'll try to try to share that experience, but I believe that similar condition can be expected in the neighborhood countries. And this is something linked with the first part we'll discuss today. This is this part about how the landslide starts, why it starts, what are the main reasons for landslide activation, what is the failure mechanism, what are the basic elements of some landslide, and we will discuss about this today. As we said before, we have these five major topics, and every topics have some learning outcomes. The following learning outcomes is that we'll show the importance of the investigation works, monitoring works, and observational methods in prediction and of slope failures, and in construction the highway in landslide areas, and in the remediation of landslides if it's activated after the highway construction. For every case study where we had some failures, some sliding of the soil, some problems with the serviceability of the highway, we'll show the case studies. We'll show the details of applied measures and failure mechanism, and the outcome should be that we learn something from those practical case studies and then try to escape the similar problems in the future when we are dealing with this kind of problems. Also, we'll try to explain so you can understand the principles of some simplified and advanced numerical modeling techniques of geotechnical structures that are interacting with the landslides. So we'll show what information can we get from the some numerical simulation of retaining walls, anchored walls, some deep excavation of foundations in the landslide area. As I said, we'll show the details of one practical example where the highway viaduct passes in the very deep landslide area, and then we'll define some main aspect of the design of such a complex foundation structure. Of course, we don't have time to explain all the details, but if, as I said at the beginning, if you have something you're interested in, you can always stop me, ask for some details, and even further, if you want to go deeper in this subject, you can try to prepare some calculations, try to prepare some design, and send me to check it and to give my feedback on that if I can help you at all. So we'll discuss about deep foundation, retaining walls, some counterweight, this stone column materials with drainages. How can it be actually modeled? To introduce it into the calculation, and then to check the safety factor of these conditions with the support measures. Okay, that was some so-called pre-course introduction where I just introduced you in what we'll discuss about in the next 4 weeks and some part of it today. So some so-called rule of the games are that you can follow the online lecture and to make it more interactive, so you can ask me something, I can answer it if I know, so we can discuss it. And if not, I'll send you the video link so you can follow it some later when you find some time for that. And at the end, we won't have some typical exam. It will be just actually like kind of a game where I'll give you some geometry and soil input data or some field test result data. So you can then interpret the field test result data to get the input parameters and do some theoretical or empirical approach to predict the bearing capacity or load settlement curve of some foundation on slope area. So it's somehow linked with this subject where we have some highway construction on slopes, and then we'll collect all of your answers and do some short discussion of why are the results same, why are different, where are the differences, what you often use as the principle of interpretation, and what you often use as some theoretical or numerical approach or some empirical approach for predicting the results of some problem. Since we are uh, using this Zoom application, it will interrupt us every 10 minutes. It just said that we have 10 minutes more on this first part of the lecture, so we can use these 5 to 10 minutes to see if you have some questions about this general information about this subject, landslides in highway construction. Do you have some information or questions to share with me at this very beginning? I would really appreciate if you have something to add, because I don't have to explain you how it looks from here, talking with discussing with this monitor. So I would really appreciate if you have some comments, some information, some questions, or something, just to at least to let me know that you are there, so I don't have to speak with my computer.
Okay, I have a question.
Okay.
Uh, so since we are learning about landslide in highway construction, I'm currently a master student of transportation infrastructure in the University of in Skopje, Faculty of Civil Engineering, and I already applied for master thesis, and it's gonna be about tunnel portal. It's gonna be
Can
about
you
the
just repeat?
stabilization.
Excuse me. I understood everything. Expect the subject of the master thesis.
It's gonna be about the tunnel portal, stabilization of tunnel portals, the entry
Okay,
and
okay,
the
okay,
exit.
okay.
So that's the information that we are going to learn in these lectures are going to be connected with stabilization and tonation of the slope of the tunnel portals. That's my question.
Actually, the most of the tunnel portals are secured by the soil nailing techniques. We may add some details about that when we will discuss about retaining walls parts that I introduced here. This is retaining walls and drainages as landslide remediation measures. Actually, in this original presentation, I didn't prepare any details on the soil. It's a soil nailing or rock nailing techniques, but why not? I can add few slides that will discuss about tunnel entrance construction. We have one similar problems in our case study part. In a case study part, this is this problem. What happened here? This was a temporary construction of the tunnel portal here, but after that, it was designed to prepare this long-term condition, and this is a reinforced earth slope. Reinforced earth slope that will support this temporary construction of tunnel portal. That is this soil, actually rock nailings, and this was a rock slope here. But the main problem occurred here during the construction of this reinforced earth slope. After the construction of this slope, failure occurred and influenced the stability of this area. So some supporting measures were performed here to stop this sliding. So it's a little bit linked to this theme, not directly, but we can add few information about how it works, since this portal construction is often temporary, not always, but it is often temporary construction, and then it is supported by some construction like this one here. So the answer is that we will give some information that is concerning that, and that may be influenced. But you can see here, this is a soil nailing as a temporary support, and this is a long-term support, this reinforced earth wall. Okay, I'm happy to have
Thank you.
to have
The
you.
reason that I asked, sorry, the reason that I asked that question is that because I'm currently working in highway here in Macedonia, and since we are working in a since it began first at the first stages of the digging of the tunnel, it fell right on the entrance of the tunnel while digging. So some of the engineers thought the slope wasn't enough stable to retain that load. So that was the mistake. That's why I wanted to know that. That's why I asked that question.
Yeah, actually, I
And
didn't
of
get.
course, the master thesis.
The connection is really poor. I couldn't get everything you said.
Okay, I'm gonna try to repeat. The reason I asked the question is that now I'm currently working in a highway construction project here in Macedonia,
Okay.
and we were working on the tunnel. I mean, the tunnel started before I was employed here, but they told me that the tunnel, when they started the first phase, the tunnel fell right on the beginning of the digging of the tunnel, and it fell right on the entrance slope. So some of the engineers told me that it fell because of the entrance slope was not stable enough to retain that load.
Okay, okay, okay. I understand. I understand. This is like you on this figure, like you had this slope failure here. If you don't have appropriate support measure.
Yes, yes.
But as the support measure usually used here are soil nailing, I'll add this support techniques when I start this part of the here of this retaining walls. That's kind of retaining wall that is used for slope protection at portal entrance, tunnel entrance. Okay, any more questions? Okay, now we'll have this interruption in. I see some questions here written in this message box. Okay, so no question. What software from us is well, there is no any particular software that I expect you to work with. You can use any software for solving this exam. You can do anything what you usually do, what you know how to use. I don't really think that some software is very much better than the other. Every software is okay as long as you know how to use it. Only when you get into details you can have some advantages of one software in comparing with the other. But really, when we are preparing from some practical work, it's not so much important if you use GeoSlope, Rock Science, Fluxys, Flux, Phase, or I don't know. So I don't expect any particular software from you to use. You can use anything you already learned how to use, or if you want something new to use, you can. I can be a feedback for you. Or okay, we have one more question about the particular problems, but we will be stopped now by this Zoom 40-minute stop. So let's connect in 2-3 minutes again, and I'll continue with the answering questions, and then I'll continue with this second part of